Namaskar. Welcome you all to this session on disaster risk strategies part 1, which is focused on structural measures for risk reduction. The last session 5, both part 1 and part 2 have focused on risk assessment and analysis for the risk informed decisions, both in terms of preparedness and response. Today we will be discussing on strategies for building resilience by combining engineering innovations with policy frameworks. Now, what are the DRR strategies? When I call DRR, please understand it is disaster risk reduction. DRR involves protecting measures to minimize disaster impacts by enhancing resilience and reducing vulnerabilities. Emphasis is on a pre-disaster preparedness and mitigation rather than post-disaster response. What is its significance? With increasing disasters due to climate change, urbanization and environmental degradation, DRR strategies are more critical than ever. For instance, the rising frequency of the floods and cyclones demonstrates there is an urgency of such measures. What is the approach for DRR strategies? A holistic strategy combining structural and non-structural measures based on specific hazard profiles. Under structural measures comes physical interventions like levees, dams, retrofitting of the buildings. Under non-structural measures, early warning system, public awareness campaigns, building bylaws, etc. comes under this. Now, let us discuss the importance of structural measures today. It plays a mitigational role. Structural measures directly reduce physical vulnerabilities by ensuring that buildings and infrastructures can withstand hazards. For example, earthquake resistant building designs in Japan have saved countless lives during seismic events. There are economic benefits out of it. By minimizing damages, structural measures significantly reduce the recovery cost and economic disruptions. Studies show that investing in mitigation is often 3 to 5 times more cost effective than funding the recovery efforts. It does holistic integration with non-structural measures. While essential structural measures are most effective when paired with non-structural strategies like policy frameworks and community preparedness. Now, let us discuss a strategy for disaster risk reduction focusing on earthquake resistant building. These structures aim to reduce loss of life and minimize damage during seismic events. Buildings are designed to absorb and redirect seismic energy, ensuring stability even during strong earthquakes. Principle behind structural resilience is number 1 is ductility. Under ductility, materials like steel can bend without breaking, preventing catastrophic collapses. Second is base isolation. Flexible bearings allow buildings to float, reducing the impact of ground shaking on the structure. The third one is energy dissipation devices. Technologies such as dampers convert seismic energy into heat or opposing movements, stabilizing the structures. There are certain building materials used for ensuring earthquake resilience. Number 1 is reinforced concrete. It combines tensile and compressive strength, making it ideal for seismic zones. Number 2 is steel structures, lightweight and highly flexible, enabling high rise buildings to withstand sway caused by earthquakes. And there are certain traditional materials like reinforced bamboo and timber provide sustainable and cost effective solutions, especially in the low cost region. Examples are bamboo reinforced homes in rural South Asia have demonstrated remarkable earthquake resilience. Now, let us come to retrofitting existing building to make it earthquake proof. Purpose behind is to strengthen the older structures to meet current seismic standards and reducing their vulnerability. Examples are retrofitting schools, hospitals and historical landmarks in urban area always create resilience. There are certain techniques which are being used for this. Number 1 is shear walls and braces, they enhance lateral stability. Number 2 is column jacketing to strengthen critical load bearing components, and number 3 is base isolation retrofits to reduce shaking impacts during earthquakes. Now, from earthquake we are moving to flood control infrastructures for risk reduction. There are certain physical structures designed to manage and prevent excess water flow during floods. It protects communities, infrastructures and ecosystems from flood related damages. Example, Thames barrier safeguards London against tidal surges and river flooding. It ensures uninterrupted operation of the critical services including hospitals, power plants and others during flooding events. Now, let us try to understand types of flood control structures. Number 1 is dams and reservoirs, which stores high amount of water. It regulates river flows and store excess water to prevent seasonal flooding. Example, Hirakud Dam in India controls floods while supporting agricultural irrigation. Others are levees and embankments. They are acting as a barriers made of earth or concrete to contain rising water levels. They are having certain limitations, risks of overtopping during extreme flood events. Third category of resilience is the coastal flood control structures. For that, one is the sea walls. It is a solid barrier to shield coastal areas from storm surges and erosion. Mumbai sea wall mitigates the impact of monsoon tides. Breakwaters, structures that absorb wave energy and reduce flooding risk, and there are natural resilience being created through mangroves and ecosystems. They are the natural solutions like the mangrove forests provide a buffer against storm surges while supporting biodiversity. For the case study, you can refer Bangladesh, where mangrove restoration programs have proven effective in reducing cyclone impacts. Next category of resilience is urban flood management, creating resilience in urban region. The challenges are rapid urbanization creates impervious structures that increases runoff, overwhelming drainage systems. Answer is green infrastructure. Green roofs or rain gardens help absorb and filter storm water. These solutions enhance urban resilience while supporting environmental health and overall health of the community. There are certain hybrid solutions. They are combining natural system with engineered structures for better flood management. There is the example, Copenhagen's cloudburst management plan integrates green and grey infrastructure to manage urban flood effectively. Now, let us try to understand what is the grey infrastructure. Grey infrastructure is a traditional engineered infrastructure built to support urban development and manage resources. There is a second term, blue infrastructure. They are the systems related to water resources focusing on their management, conservation and integration with natural and urban ecosystem. And the third is green infrastructure. They are the systems and features that utilize natural processes to deliver environmental, societal and economic benefits. From urban resilience, let us move to landslide prevention and slope stabilization that creates resilience against landslides. Landslides threaten lives, infrastructure and ecosystem, particularly in mountainous and hilly regions. For example, landslides along highways in Simla disrupt transportation and endanger lives. What are the approach to prevent it? A combination of engineering solutions, biotechnical interventions and land use management planning ensures long term slope stability. Integrated approach reduces risk effectively while protecting local communities and ecosystems. There are certain engineering solutions for landslides. The techniques are creating retaining walls. Reinforced walls hold back soil, prevent slope failures and stabilizing the terrain. Rock fall barriers, steel netting or barriers placed along vulnerable roads protect communities from falling debris. Third is the drainage system. Properly created and designed drainage prevent water accumulation, which often triggers landslides. Example is gabion walls made of mesh and filled with rocks are used in Nepal for their affordability and environmental benefits. There is another solution, biotechnical methods for mitigating landslides. Vegetative stabilization is the one category in which deep rooted plants help bind the soil and prevent erosion, that reduces the risk of landslides. Second is eco-friendly techniques. Material like coir or jute mats stabilize slopes while allowing vegetation to grow naturally. And the third very important is community participation, training locals in planting and maintaining stabilizing vegetation, and it fosters ownership and sustainability to the local community as well. Another category of landslides management is scientific land use management. Number one is zoning and regulations. It prohibits structure construction in high risk zones to minimize exposure. Example is Darjeeling Hills landslide susceptibility zonation project mapped landslide prone zones using GIS, remote sensing and field surveys. Construction and road building in high susceptibility zones are totally restricted. Guidelines are issued for control urbanization in moderately prone areas. National landslide susceptibility mapping program identified vulnerable zones in Darjeeling under Geological Survey of India. Second approach is reforestation. Planting trees and shrubs restores degraded slopes and it improves soil stability. Let us discuss a case study. Reforestation in western Ghats of India has significantly reduced the monsoon induced landslides. Now, next one is early warning system. Through early warning system, the technology is sensors, inclinometers and satellite which monitor slope movements. They detect instability before landslides occur. Community training, educating the locals to recognize warning signs such as cracks or unusual soil movement and establish evacuation plans in the region. Example is National Remote Sensing Center in India uses real time satellite monitoring to predict and mitigate landslide risk in Himalayan region. Now, what are the challenges in structural measures? The first challenge is cost. High construction and maintenance expenses make large scale structural infrastructure very challenging. Second is technical expertise. Limited availability of skilled manpower in remote or rural areas hinders proper implementation. The third is environmental impact. Engineering solutions such as large retaining walls can disrupt local ecosystem and biodiversity. Then how to address these challenges? Number 1 is the capacity building, train local engineers and community leaders in disaster management and structural interventions. There are certain blended approaches that integrate engineering solutions with nature based measures for sustainable risk reduction. And the third is funding mechanism. Public private partnership and innovative financing tools can bridge resource gaps. Now, there is a integrated flood management. There are certain hybrid approach combines traditional infrastructure like levees with green solutions such as wetlands. Singapore's Marina Barrage integrates a tidal barrier with a storm water reservoir to manage urban flooding. Climate resilience ensures solutions are adaptable to future extreme weather events and rising sea levels. Let us discuss some case studies. Number 1 is earthquake resistant designs in Tokyo. Their high rise buildings incorporate seismic dampers and base isolation systems, thereby reducing the earthquake impacts. Under the flood infrastructure, the Thames barrier in London protects against tidal surges, safeguarding millions of residents and critical infrastructure. Under land stabilization, retaining walls and drainage system in Nepal's hilly terrain have effectively mitigated landslide risk. From this, let us move to monitoring and maintenance of the system. There is a need of regular inspection of the critical infrastructure such as drainage system and retaining walls, and that will ensure its functionality and safety of the system. Community role is very important. Engage locals to participate in monitoring and maintaining shared infrastructure promoting sustainability. Still, we are facing some challenges. Insufficient funding often lead to neglect, compromising the long term effectiveness of the structural measures. Then what are the future directions available? Number 1 is the technological innovations. It leverages artificial intelligence and machine learning to improve hazard prediction, resource allocation and structural designs. Second is sustainability. It prioritizes green infrastructure and renewable materials to reduce environmental impacts. Third is the reform of policy. It advocates for integrating climate resilient standards into national development policies. Then what is the way forward? The way forward is number 1, investment. Allocate increased funding to high risk areas to strengthen disaster resilience. Number 2, foster collaboration which foster partnership among governments, NGOs and private entities to enhance resource mobilization and implementation. The third is capacity building. It focuses on training local communities and professionals to ensure long term disaster preparedness. With this, we are going to close, but prior to closure, let us discuss the summary of the key points. Number 1 is structural measures such as earthquake resistant buildings, flood barriers, landslide prevention techniques, and they are very crucial for minimizing disaster impacts. Second learning is integrated approaches combining engineering solutions with nature based methods enhances resilience and sustainability. The third is importance of policy frameworks and compliance in ensuring that structural measures are effectively implemented. The final note before we close: a resilient infrastructure depends on number 1, collaborative approach, integration of technological innovations, third is the policy reforms, and fourth is community action. And what for all these are? They are for to safeguard the lives and livelihood against disasters. Thank you very much. Namaskar.